Welcome everybody to this demo session on cloud performance engineering and DevOps and site reliability engineering course, friends. Uh, Let me introduce myself. My name is Roshan. On my IT experience, I have more than 18 years of IT experience. I am with Isha from last 6 years. Uh, Teaching is one of my hobby, you can say passion, sharing knowledge. So that's why I take this up. I'm a working professional as well. I'm working as a principal SRE with one of the reputed retail giants of the world, friends. Um, I started my career as a Java developer. I have been in Java performance engineering, Java particularly. I have worked with uh, 4.5 years of experience in Java performance engineering. In general, I have 8 years of performance engineering experience, and then I have moved into DevOps and SRE consultant role. Friends, I'm currently working as a principal SRE. This, I hope I'm audible to all of you. I see some.
Yes, yes, you are.
Okay, I request everybody to be on mute, please, so that we can have a fruitful discussion. Thank you so much, everybody. Okay, so that's background about me, friends. I would like to know about you in short. Let me give you a format. Before I start the demo, I just want to know about my audience so that I can take up topics accordingly. I can present it accordingly. So just quick thing I need from all of you from you have the chat option in the meeting, right? I need you to write your core skills, like if you are a performance tester or engineer, uh, years of experience, or you're into automation, QA automation, or you are into DevOps, or you are into production support. Just write those things. Um, and then how many years experience you have, right? So years experience, that would be enough, friends, for me as of now. Could we do that, friends, quickly in the chat? Okay. I'm starting to get the responses. Perfect. Okay, Vinod, good to meet you, Vinod. 15 years experience, performance testing engineering. Okay. Psych, performance testing 9 years, performance engineering 7 years, and Sita. Okay. The three people. Okay, Srinivas, 12 years, performance testing and engineering, test automation. Hussain, 12 years of experience. Okay. Performance tester engineer, 9.5, 9 years of experience. Arif. Okay, 3 years into performance testing. Gita. Nishan, 6 years of performance testing. Okay. Raju. Perfect. 4 years performance testing. Murat. Automation Java, 8 years. Performance test engineer. Poonam. Mali. Monitoring tools admin. Okay, Mali Arjun. Which tool you have been doing the administration, Mali Arjun? Nishan, 6 years. 3 years experience, Gita. Okay, Priya. Okay, AppDynamics, status, data, Dynatrace, Splunk. Okay, perfect. 6, 7 years. Okay, I see most of us are Abbas, more than 8 years experience, monitoring, observability, 5 months back. Okay, infra engineer. Okay, perfect. Perfect. Good. Good. Thank you for this. Good. I get to understand now, friend. Most of us are performance tester engineers. There are observability engineers as well, monitoring admin as well. There are QA automation folks as well. Perfect. Good to know about all of you. I have not, I see Amia, DevOps, app, prod support. Okay. Perfect. Okay. Good. Thank you so much, everybody. Okay. So let me get started, friends. See, this course, I'm running this course with Isa from last six and a half years, right? And we have seen growth about this course. You will understand more about the course in some time, right? But you will understand that what we cover is the fundamentals, right? We don't assume that the audience knows anything. That's the main uh, that's the thought process I have when I came up with this course. That was the thought process because I was getting people which are not comfortable, who are not comfortable with cloud, not comfortable with Linux. They do not know what is containerization, Docker, what is automation, and they're stuck as a performance tester mostly, right? And they were not able to upskill themselves and to proceed in the career. That's where it came up, and that's the main essence of this course, that we take it from very scratch. If you do not know cloud, if you do not know Linux, if you do not know what is containerization, Docker, Kubernetes, if you do not know what is, how do we do automation, how do we make sure resilience, we can maintain observability, how we do. So if you do not have those background, if you have been just doing performance testing with some tools or engineering, some troubleshooting here and there, and that's where this course, right, that's the essence. Okay, I will talk more about this course, friends. Give me 1 hour and you will understand more about the course, and then we will have Q&A, right? Mostly I need 45 minutes to 1 hour. I'll complete that, friends, and then you'll have a complete understanding about the course. Okay, so before I talk about the course curriculum and how do we go about the course, right, I'm going to ask everybody a question, simple question. How many of you agree, friends, that these things we should know it? Whether you are a DevOps engineer, you are into production support, you are into performance testing engineering, or you are into QA role, what is your understanding? Or you are an observability admin, whichever skill you are, I need your honest opinion about these 4 things. Where do you see these things? Do you think these things are absolutely required? Or no, I can manage my career without these things. What do you think? The topics which I'm talking about is DevOps, the microservices, the containers. And in the containers, I'm talking about the Docker, Kubernetes, cloud, I'm talking about AWS, the infrastructure, and DevOps, I'm talking about the automation, understanding of the deployment process. How do we automate CI/CD pipeline and those things? What do you think, friends? Important or not? Or you can manage your career without these things. What do you think as per the current market trend? You can feel free to unmute yourself if you want to speak something, some
Definitely very
points.
important. It's needed.
Right. Right. Yes.
Yeah, it is current affair in market, so I think it's required for everyone who is in these fields.
Right. Good. And I'm talking about this from last 6 years, friends, and still relevant. Look at this, right? This course, I'm showing this slide from last 6.5 years, and you think still it is so relevant because these things are not very new, right? But they're not very old also. If you talk about Docker, Kubernetes, they have been around in 2015 around, right? Some 10 years back, we have containers. Cloud, we have cloud popularity from 2012, 2011, right? We have cloud, we have picked up. And DevOps, everybody talks about DevOps now. How do we automate all these things, right? So we'll go in detail, friend. But we all agree on one point, that these things are very, very important. Is there anyone who doesn't understand, right? Please feel free. I'm here. I want my goal here today that after 1.5 hour of session today, demo session, I want you to learn something. Okay, that's all. The entire main. I don't want you to get a feel that session was wasted, right? That is the main important. Anybody who doesn't understand my in question, feel free to unmute and let's discuss, friends. But if you all agree, we will proceed further. Okay, because I see a lot of chats. Important, and not future assets. It's not future technologies. It's going on. Okay, it is wrong to say it's a future technologies. No, it's going on very much right now. Okay, and I'm going to tell you about from since when. Okay, so the next slide will tell you about the importance of these things, where these things are placed. why these things are so relevant. Okay, you'll understand from the next slide. I'm going to show you my next slide. Here it is. So why these things are important, friends? The DevOps, the microservices, the containers, and the cloud. Why these things are important? Because if you look at the evolution, the software development and deployment evolution, you will understand that we are currently in this phase and it's going on from past 1 decade. It's not new. So if I talk about the infrastructure, let's say from the rightmost side, earlier, if you had a business idea, see, software industry has started around 1980s. It's not from a very long ago, right? From 1980s. So you can say like maximum 50 years back, 40 to 50 years back. We're talking about the software thing. So earlier, if you had a business idea, there was a no option for you to get a infrastructure. You have to set up your own data center. That was the solution. The companies like the likes of Microsoft, IBM, HP, Oracle, right? We have been using their software from quite some time, and all they have is the data center. They own data center. Do we all understand what a data center looks like? Think like a multi-story building in the outskirt of a city, friends, and all the rooms, big rooms, are full of servers, right? Full of servers. If you have to imagine, friends, I'll just show you. Like this. Okay. Just adjusting. There's a top. Okay. Again, in the teams, I get this top thing, friends. So little adjustment is required. Now, if I just show you, friends, a picture of a data center, you'll understand. It's a Google data center. Imagine a building like this, right? A building like this, or a building like this, and all the rooms are full of servers like this. This is what we call a data center. What do? We have a lot of servers. Our laptop is also a server. We have the CPU cores, the RAM, storage options, right? Companies use it, right? To host applications, to store data, and there are various regions. So if you had a business idea back then, there was no option but to set up your own data center. Right now, friends, we don't have to set up a data center. Why these many startups have come? Do you think all these startups, Swiggy, Jmeter, Ola, Uber, whatever the way you see around, the application that's come, do you think they have their own data? No. Okay, they use one of the uh, prominent data cloud providers nowadays, like the likes of AWS, Amazon Web Services, or Microsoft Azure, or Google GCP, Google Cloud Platform. They use this. We have Alibaba, we have DigitalOcean, we have various clouds now. We use that. That is the situation. And now, as a software engineer, we should know how do we use cloud? Where are the servers? How do we create a server? How do we get the storage? How do we do auto scaling? How do we create a Kubernetes cluster? Let me ask you this question. What I have got this very because I get a mixed response. Do we all know here? Okay, ask you yourself. Do you know the application you are testing or you're working on? Where it is hosted? How it is hosted? Is it running in a VM, virtual machine? Is it running in a Kubernetes cluster? Okay, first of all, the understanding of this is required or not, friends. I just want to know simple answer, because I have got the response from most of us whenever I have asked this question that I don't have a clue. I just test my application. I have my application, I know, but I don't know how it's running in a VM or in a Kubernetes. First of all, is it important to know or not, friends? Yes or no? What do you think?
Yes, it's very important.
Yes.
Yeah, it is very important.
Right? And if you do not know, friends, let's say here I can tell you the few of us not sure because but I've got a response. I do not know, but I know I test my application. I know I just run my load. I have an API. I have a web server. I just test my load and I get some numbers and that's it. If we do not know the backend, the server, is it running in a Kubernetes cluster or a VM, how would you do capacity planning? How would you know how much cores was used? How much CPU was the usage? And if and who okay, in this organization, in any organization, who has the responsibility of capacity planning, friends? Okay, when I say capacity planning, I'm trying to say, let's say I have given you the prod load, some TPS I have given you. You know the prod load. Who owns this responsibility in the organization to give me the number of servers, the number of cores, and the RAM required to run the peak load, to run the prod load? Who has the responsibility in the organization, according to you?
Performance team.
Right? Do we all agree? Because I have got these mixed answers also. Somebody says architect, somebody says developers. It's performance team. Because who runs the load in the organization? Prod load. Only performance team runs. Only performance team would know what. First of all, it's very difficult to simulate all the use cases, I understand, but we have to simulate 70-80% of the cases. We have to set up auto scaling so that in case some load, extra load comes in which we have not planned, servers auto scales. So if we do not have the understanding of the infrastructure, how how we would be doing auto scaling, how we'd be able to understand how much cores and the RAM would be required. So it's a must, friends. So the understanding of cloud goes to a deeper level, right? And DevOps engineer, production support engineers cannot live without, because they deploy application, right? At least the DevOps engineer, they deploy applications. Whenever developer develops something, they have to deploy the code in various environments. Without the understanding of the cloud infrastructure, how can they deploy applications? So it's very important, friends, the cloud. Feel free to ask any questions at any given point in time, right? Feel free, friends. I do not mind any questions. No questions is small, big, or difficult or easy. Feel free to ask any questions. Okay. That's on the cloud part. Now, why we talk about containers? Friends, 10 years back, a revolution has come. Like around 2000, a revolution came. We talked about virtual machines. It was a great thing. Earlier, friends, when the software deployment started around 1980s, we first of all developed tiny little applications, few KBs, MBs application, and we used the entire physical server. Only one small application was running in the physical server, big physical server. We were wasting a lot of resources. A lot of resources were unutilized. Then there came a revolution, friends. Virtualization. Can somebody help me understand this? What is virtualization? What is virtualization?
Fragmenting a physical machine into multiple virtual machines.
Right. What is the main goal? Why did we do that? What did we achieve?
So I think if suppose, for example, if we have, we can suppose we have a requirement of 150 GB of server, so we can create instead of creating different application, we will use one server, and we generally virtualize that server, and we can expose our application on it.
Yeah,
I
but
think.
we are not answering why do we need to do that?
Yeah, maximum utilization of resource.
Yeah.
Perfect. right? The understanding, the idea has always been the efficient, optimal utilization of the resources. We were wasting resources there by just deploying one KBs, MBs application in the big physical server. We use the same hardware and we could create VMs. Right now, let's say in your laptop, you have, let's say 16 GB RAM and let's say 16 core CPUs or 8 core CPUs or 8 GB RAM. We can create multiple VMs in your own laptop. We can use the resources of our laptop and we could create VMs and we can install different OS, different applications, and we can run them. So think from a bigger scale. Think from 100 cores, 500 cores, and we are splitting it, creating VMs, right? Just think about a bigger scale, and that's the virtual machines. And the idea has always been the efficient resource utilization and cost optimization. That has been always been the understanding. 10 years back, another revolution has come. Containerization. We observed that even the VMs are not fully utilized. The VMs overall are like 20 to 40% utilized. That's it. Though we could create, it's much better than the physical server, yes, but utilized. So what did we do? We took one VM and we containerized containers. We created containers and we could create as many containers till its resource exhaust. So we would make sure that we utilize one VM to its complete full potential, to its complete resource, whatever we could do. And then only we would go ahead with the second VM. So again, the goal has been the same: efficient utilization of the resources. And containerization is a technology that we should all learn. Right now, let me ask you this question. Where is your application running? Is it running in a VM or is it running in a containers?
In this
Container-
modern
containers.
world, everything is in
Containers.
containers and Kubernetes.
Right? Everybody talking about containerization nowadays. Yeah. Nowadays, I've seen people speaking more about it. I have been telling about this, that we should all learn this from last 6 years, right? And now I'm getting more responses that is running. First of all, very few people were answering that containers. Everybody, friends, every company is going to will be in containers because it gives the utilization of the resources, basically cost optimization. In the cloud, cost is a topic which is very close to the senior management, right? Because everybody talks about cost optimization. Everybody across, be it any bigger company or a smaller company, cost is the major factor in the cloud environment, cloud setup. Everybody talks about the cost. And if you have a technology that without compromising on the availability, performance, reliability, I'm able to optimize the cost, why not adopt that technology, right? Let my application run in the containers. Let's use Kubernetes. We have in Kubernetes, we have a lot of features, auto healing features, auto scaling features, auto deployment features. It's very, very important, friends, to learn containers. If you do not know about containers, find a way to learn, okay? Find a way to learn. Find a way. Anyway, we should know that, okay? If not, like, we'll be far behind, friends. We are talking about AI world now. We are talking about automation. And if you don't understand the basics, right? How the application is being deployed, like ABCDs, alphabets. We have to know that. And then on top of that, we have to use our Gen AI tools, AI agents to do more automation. But the fundamentals has to be clear. Like, even to do automation, friends, any sort, the fundamentals have to be clear. Even to write a correct prompt, ask the right question, we should have the fundamental understanding. And we focus on the fundamentals here in this course. Overall, that's what you will understand. Now, coming to the application architecture, we have been progressing, friends. Earlier, we were using mostly monolithic applications. Monolithic, when I say mono means single, lithic means big, because they did not understand the importance of microservices. And we had a bigger code base, kept on increasing. The code base of our application kept on increasing. And it became so big that it was difficult to manage. Issue with one of the modules can impact other modules. In fact, can impact the entire application health. So it's better to split the modules. If I tell you, friends, simple example, if I tell you everybody uses Swiggy application, right? Swiggy, Ola, Uber. If I tell you there's a feature called notification, right? Whenever we order our food or book a cab, we get a notification. If I tell you, if my notification feature is not working, I will not be able to book my cab or order my food. Will you like such application? First of all, I would say what notification has to do with my main business? Yes or no? Will you like such application? If issue with one functionality going to impact other modules, nobody likes it, right? We will first think why notification module has to do with the core functionality. That is what the problem with monolithic. When you put a lot of code put together, packaged like a dependent code base, I'm calling the functions from one module to other modules, I'm calling the functions, and the functions are being called anywhere and everywhere across all the modules. Basically, you get a huge dependency, and so with one function could break the other application, other modules, and in fact, it could bring the entire application down. So we have to split it. Split the code base in a manner which gives us application availability. We all know, friends, that Make My Trip or Clear Trip or any such Ease My Trip, all these websites, they use APIs of flight carriers, Indigo, AirAsia, Air India, right? We all know that. They use it, the flight carriers. If my Indigo website is down, do you think my Make My Trip would be down?
No.
Because they are two separate applications. Even though, yes, what would happen, the impact that when I go to source, destination, date, when I search, I may not get the details from Indigo. Indigo flight details I may not get because the Indigo website is down, Indigo application is down. Maybe the API is not working. The whatever API I'm calling, that's not working. But my Make for other flight carriers, I would still see the details. So the point is, the issue with one module should not impact the module. Even though Make My Trip makes calls to different flight carriers, if one API is failing, it doesn't mean my entire application will be down. Make My Trip will be also impacted. And that is what microservices does. Your website, one application, it calls Make My Trip is a separate module. It calls various flight carriers API to get the details to book the flights, hotels, so many things, right? One module should not impact the modules. So basically, microservice architecture gives you availability. The issue with one module gonna be only contained to that particular module. It's not gonna be impacted other modules. If notification is not working, fine, I would not get the notification on my food. That's fine, but still I'll be able to order. That's microservice architecture, and we are talking about microservice architecture, friends. And the best part is we are making from our transition from monolithic to microservices and the physical server to containers from the infrastructure side. From infrastructure side, we are making optimization on the infra cost. On the application side, we are making our application highly available. And when you deploy microservice on the containers, that's the best thing. And that's what we do. We deploy microservices, we develop microservices, and we deploy in Kubernetes cluster. That's happening, right? Most of you just told that your application is Kubernetes. I'm going to mostly assume that you are mostly working on microservices architecture. Yes or no, friends?
Yes.
Yes.
Coming to the last part, friends, the development models. How we go about developing a software. What is the process? What is the methodology I've adopted to develop my application? When we started with waterfall. We had a lot of problems with waterfall because in the waterfall, what we did, friends, we developed all the everything, whatever we discussed about the software, we developed everything once. We took 6-8 good time to develop everything, whatever we have discussed, the features wise, we developed. And after 8 months, we started to test. What would happen? You're going to get surprised, right? You get surprised like application not scalable. The requirements have changed. Customers did not like it, or customers want to make some changes. We underwent a lot of problems, but that's how we started. Not a problem, because that's how we started, right? We learned from our mistakes. We have made progress. We have advancement, and we talk about agile. We're still using agile. What is agile? So we split the development into phases. We call it sprints. Okay, in one phase, in one sprint, I'm going to develop 4 or 5 features. I will develop it. I will test it. All sorts of testing, functional, performance, security, all sorts of testing. Then I'm going to show my application to my client, and I'll take the feedback also. So this is the feedback loop. I'm developing one sprint. I took the feedback from my client and again went ahead and taken the more features, adopted the feedback, again did all sorts of testing, and we continued this process. Eventually, the end product that we're gonna get in Agile is gonna be much better than the waterfall product. Yes or no? We are not gonna get surprised here. We are taking constant feedback from the customer, our client. We are testing every source of testing we are doing. Performance, scalability, endurance, stress, security, every testing that we are doing, functional application, everything we are doing, we are taking feedback from our customers, from our client, and we're going to be much better. But there was only one problem, with Agile. I'm going to ask this question. When the code is ready, let's say developer, we are working on a features or set of features, and the code is ready, let's say. Developer says code is ready. Developer has pushed the code to GitHub, Bitbucket, somewhere in the code repository. What is the eventual goal? Eventual goal. What do we want to do with that code, friends? What is our goal? What do we want to do with that code? When the code is ready, what is the ultimate goal?
It should be on production.
It should be production, right? That's the ultimate goal. But what we did, we deployed in a lower environment. That's what we do, right? Because we cannot directly deploy the code to production. So we deployed in lower environment. We do all sorts of testing. Functional testers check functionality. They raise defect. Developer fixes it. Then it goes to performance. Same thing goes to security. They can do parallel also. But eventually, this entire process takes time because these things are being done manually. That's the only problem we had with Agile back then. What is the solution, friends? How can we make this better? How can we make this manual process better?
Automate.
Through automation. If the code is ready, why can't I write a script? Let's say the code was written in Java. Then why can't we write a script to build the code in Maven? Right? We can write a script We can write unit test cases also, and Maven can help me build the code. When I say build the code, compilation and unit testing, and eventually the packaging, jar file, war file. Once I get the jar file, war file, why can't I automate to deploy in a QA environment? Why do I need a manual intervention? Okay, yes, that's doable. I deployed my code to QA environment, depending on whether running in container or VM, whatever it is. Okay, I deployed. Then why can't I automate my functional testing? I can write a script in Selenium, and as soon as the code gets deployed to QA, my testing script should trigger automatically. It should regress for all the test cases that we have written, scripted, developed. Okay, that's done. Then why can't we write a Jmeter script which could trigger when the functional testing is completed? We can be ready with our scripting. We can be engaged more early with the developers. We would know what API they're developing, what they're developing. We can understand the load from product team. And if you do not know, if you already have details from prod, we can get it. But our scripts can be also ready, performance testing team, load testing, and we can compare with the previous build and make pass, fail, check all the metrics that's important for us: errors, response time, throughput, status code, saturation, CPU utilization, everything, right? We can check all those things, and if things looks good, we can pass it, and same thing security team can do. So these things can be automated, and this is what we call DevOps. DevOps is nothing but the collaboration, how the development and operations team are collaborating with each other to make this process streamlined, to make this process smooth. When the code is ready and till we deploy the code to production, why do we want to do manual steps? All these things can be automated. And that is what we call a CI/CD pipeline, continuous integration, continuous deployment. And we need to use tools like Maven, Selenium, Jenkins, Jmeter, Fortify. We need to use, and deployment, depending on deployment, Docker, Kubernetes, or VM. We need to use these tools, right, to get things done. And that is what DevOps focuses on. So DevOps focuses on SDLC, process automation. There is no problem as such with the way we are developing the phase-wise development, but we should bring in automation. That is what we should do. And that is when, friends, these things are so important. Now, do we all understand now why these things are so important? DevOps, microservices, containers, and cloud.
Yeah.
Yeah.
Right. So this the course, right, that I have is based on these 4 things. On the cloud part, we talk about AWS in detail and in depth, whatever required. In containers, we talk about Docker, Kubernetes, again in detail, whatever required. We understand microservice architecture quite well. And we talk about automation. We talk about CI/CD pipeline automation. And we talk about other automation. And we talk about Linux automation, Linux shell scripting. We talk about Terraform automation, infrastructure automation. We talk about configuration management automation like Ansible does. We talk about monitoring tools, observability here in this course. Right? So I'm going to walk you through the course, friends. Now you would understand better on what was the thought process behind this course. So I'm going to take you to a link, friends, the course link. Okay. And let's walk you through. Is the font size good for all of you? Let me know.
A little bigger will be better.
Bigger? Is it fine now?
Yeah.
Okay, perfect. So I'm going to give you this link, friends, all of you. I have few demos attached here. You can go over it. And that's what we are doing right now. Demo I have taken from the last batch. September batch, right? And you get the same thing that we are doing right now. Same thing I would have explained there. And day one, which going to happen tomorrow. So anyway, so the course is this, friends. We talk about cloud. As I told you, the topics are listed. I will not talk about topics in detail, but no, it's enough for you to be a good performance engineer, good DevOps engineer, and a very good SRE engineer. Okay, that's what I would say you. And good production support, you're going to be upskill yourself as a DevOps engineer. Enough, good enough for you. We talk about from very scratch, what is cloud, on-prem definition difference. We talk about a lot of services, 20 to 25 services, important services we cover, about the server, storage, how do we create users, manage users, networking, databases. We cover a lot of things here in this course. Cloud part. As I told you, what I have found, friends, that we are not comfortable with Linux. Okay, yeah, I have got a question. Siba, go ahead, Siba Rani.
So in AWS, right?
AWS.
If you go, so just want to know what if you on the AWS.
What is AWS or what all we cover in AWS? What is the question?
Yeah, what all we are covering in
Okay,
services?
okay. Yeah. So we cover, as I told you, from the server. So what do we do in AWS? We get the server. So we have EC2. We have IAM when we create users, IAM services. We talk about database services. We talk about networking. We talk about storage services. We talk about load balancer, auto scaling. We talk about cloud formation. About more.
EFS.
Yes,
Those.
that comes under the storage services.
Okay. So here we are just doing the developers, or we are writing any automation code in.
We will talk about that. That's that cloud part. Automation is coming. We will cover that. What's coming? What I'll be covering in the automation part. I'll be talking about that. So this is on the cloud part. When I say cloud part, infrastructure. How do you create infrastructure? Right? Understanding of cloud. Then automation. I'll talk about that.
Okay. Thank you.
Sure. So to keep it to
Person
answer.
you're talking about only non-functional testing only, right?
What come again? Non-functional test. See, non-functional testing, performance testing, or security testing, that's separate thing, right? That's we are not talking about
automation.
any test.
He asking like automation comes to like functional testing, right? Automation.
Again, that's we need to understand when we talk about automation here, we're talking about automation skills required by an SRE engineer. We have different automation. When I say automation, okay, let me give you a simple example to make you understand. We create a lot of servers in the production. We deploy a lot of applications in the production. We talk about, just now we talked about CI/CD pipeline. Again, it's automation. Who does all those things?
It will create automatically by scripting.
Yeah. No. So where would you put it? Would you put it with the QA automation team, or you would put that to DevOps or SRE engineer?
DevOps.
DevOps or SRE engineer, right? So that is what the automation. That's the difference between automation. When we talk about QA automation, we talk about functional automation. We have a web page or API. We are doing functional validation of that. That's a different automation. That automation talks about the functionality of the application. But this kind of automation, we're talking about different automation, infrastructure automation. If the issues come, production issues come, what type of automation you can do, right? Infrastructure automation, how would you create so many servers? How would you deploy applications? Those things also require automation.
So this course is
currently,
mostly, yes. Okay.
Currently, I'm facing like my client is asking you front-end performance testing for mobile.
Okay, I would do one thing. Can I get one thing? I requested in the beginning. Can I get some 20 minutes more? Then we'll open for the Q&A.
Okay.
From all of you. Can I get that? So that let me walk through this let me just make you understand about the course curriculum, and then we'll discuss more in detail so that you can ask more relevant questions about, so that you have a complete understanding about the course, and then you can ask
Just
me questions
I
accordingly.
have one question. Is it cover content performance testing, web and app?
Again, performance testing, again, I have to go in detail. What are you expecting? So can I get 50 to 20 minutes before I answer any of your questions?
Yeah, okay.
Vinod, you have raised your hand. Just give me some 10-15 minutes more and we'll be done with the course
Sure,
curriculum,
yeah,
and then
sure.
I'll take up questions. Okay. So this is on the cloud part, friends. Okay. Now, what I have realized, people are not comfortable with Linux. How are we comfortable with Windows? Let's say if I ask you, open a notepad, edit a word, replace a word, install an application in Windows, do something in Windows. People are comfortable. But if I ask the same thing in Linux, what the response I would get? Not sure. Most of us, right? I'm not saying all of you. Why Linux is so important? Let me ask you this question. Why do we need to talk about Linux OS? Why it is so important? Why it is so relevant? First of all, do you agree it is relevant or not? First, let me understand that. Do we all agree that understanding of Linux OS, working with Linux OS, just doing normal operations, how do you do in Windows, is it important or not?
Yeah, it is very important.
It's important.
Right? And
Yeah,
that's
it's
the thought.
important. Yeah.
Right. And that's the thought process, friends. Because what I have realized after discussing with many folks and many years back, right, that we are not comfortable with Linux. And that's why this course, this topic, because when you have to troubleshoot some issues, whether you are a performance engineer, tester, or SRE engineer, or DevOps engineer, production support, we have to go inside the Linux box and do something. It could be related to installation. It could be related to the monitoring. It could be related to something else. We have to do something, and we need to be comfortable. Running Selenium or running Jmeter in Linux box also is one of the important roles. How do we do that? So the understanding of Linux is so important. Let me ask you another question. What do you think 98 to 99% of deployment, whatever the application that you see around, Swiggy, Ola, Uber, Make My Trip, Facebook, Make Instagram, LinkedIn, whatever you use, where it is running, Linux or Windows? What do you think?
In Linux.
Linux machine.
Yeah.
All the applications running in Linux machine. And we don't know how to log into Linux. Is it a problem or not?
Yep.
That's why this course, friends. That's why this topic, and we discuss in detail about this, right? Then again, we talked about SRE topics like understanding of high availability, understanding of reliability, fault tolerance, what is disaster recovery, the topics of SLIs, SLOs, SLAs, error budgets, how do we manage incident, change management, right? So we need to understand that. So we talk about this in this course. We talk about architecture, as I told you, microservices, monolithic applications, event-based architecture, and the containers, which I was talking about, the Docker, again in detail, very much in detail. How do we create? Everything is hands-on, friends. Everything is hands-on. You will see me doing stuff. When I say EC2, I'm going to create server. I'm going to log into the server. I'm going to install the applications. I will run, when I talk about containers, I'm going to run web container, database container. I'm going to show you how it's running. How do we go inside that? How do you open the database terminal? I'm going to show you creating containers, real live in the session. Everything is hands-on. That's how you will learn troubleshooting. We have to be hands-on, and every topic that we're talking about is hands-on. Docker is a container engine. Docker helps you to create containers, but the features of Kubernetes are very important. The auto healing, auto scaling, auto deployment, We talk about Kubernetes in detail. Again, I'm going to show you creating the cluster. I'm going to show you in AWS. I'm going to show you in EKS cluster. I'm going to create EKS cluster. And I'm going to show you things. How do we create cluster? What is a pod? How does it looks like? How do you create a pod? How do you deploy YAML? Services. What is services? What is deployment? What is replica set? What is ingress? Most important, the auto scaling, right? HPA, cluster auto scaler. We'll talk about that in Kubernetes. Then it comes the Jenkins part, the DevOps part, CI/CD pipeline. We talk about that. How performance engineering fits in DevOps. How do we do CI/CD pipeline? Using, I'm gonna show you pipeline creation. I'm going to install Jenkins. First of all, I'll install Java. I will install Jenkins. I'm going to create jobs, freestyle job, pipeline job. I'm going to create Maven job, and I'm going to show you things. How do we create a pipeline? How it follows? How do we do that things? How do you create a performance testing job to run a Jmeter in a pipeline? CI/CD pipeline we talk about. This is automation, CI/CD pipeline, help for the DevOps engineer. We'll talk about resilience. How do you achieve resilience, availability using AWS services? The focus is on one cloud. I get this question, why one cloud, Roshan? First of all, if you do not know cloud, you have to learn with one cloud. And if you know one cloud, it's easy to learn other cloud. Simple. Like if you know a tool, monitoring tool, it will not take long for you to learn other monitoring tool. You understand the architecture, you understand the process. Same thing goes in the cloud. Same thing goes for the performance testing tool. Same thing goes with anything. If you know one cloud, you should start with one cloud, and that's how you learn other cloud. I have been working on multiple clouds hands-on. I have been working on AWS, Azure, GCP, Oracle Cloud Infrastructure, OCI. Started my career as a one learning one cloud, and slowly when I got the opportunity, I can work on any cloud. It's about how do we understand this, because the use case remains the same. It doesn't matter. You get the server everywhere, you get the storage everywhere. We talk about resilience. How do we achieve resilience? How do you make our application highly available, reliable, secure? We talk about a lot of security services in AWS. A lot of security services we cover in AWS, right from the IAM to how do we do private connection, guard duty, what is the importance of flow logs, WAF, sealed, how do we do that? How do we protect from DDoS attack? So we cover a lot in detail here, right? So that's on the automation part, friends, and on the resilience part. On the observability, we take up 4 kinds of observability. On the tools perspective, we cover 3 tools. One is the AWS service, CloudWatch is AWS service. And other 2 tools are Prometheus and Grafana and the Elasticstack. We have taken open source because if you know architecture, if you work on open source, it's very easy to work on commercial tools. That's the thought process. Today I have to get a Dynatrace for my application. It's so easy because they have support. If I have stuck with anything, they're going to help us. But it's not the case with open source. We have to know ourselves. How do we install, set up, create dashboards? So that's why we're talking about that. And we use Linux shell scripting to the monitoring. So we take up these things in the observability part. And we talk about various metrics that we capture. How do we go about troubleshooting an application? Friends, we talk about Java performance engineering. If you have worked on Java applications, so important because see, Java is going to be here. All the enterprise applications still use Java. We have got a lot of tools coming up. We have Go coming up, Python for automation. But whenever it comes to the enterprise applications at big scale, which tool we use, which language we use, friends? It's still the Java. Spring Boot, Java applications. So it's still relevant. We should know how do we troubleshoot the Java applications. How do we know the issue with Java application? What all we monitor? How Java application manages memory? What all do we have in heap? What all GC algorithm we have? What happens in each of the GC algorithm? What is GC log? If I give you the heap dump, we have something called shallow heap and retained heap. What is the difference? Why do threads are important? How Java manages thread? We talk about these things, troubleshooting part of Java applications. We talk about automation. I told you CI/CD pipeline automation we do already. We talk about automation of infrastructure. We talk about configuration management tool using Ansible. I show you a couple of shell scripting and Python scripting demonstration. How do we do that? Okay, so this is what we offer as part of course, and on top of it, we provide Java, core Java and Python recorded sessions. So it's a very, you must be thinking it's a very vast course. How Rossington planning it? So friends, to plan this better, we have split into recorded sessions. We provide some recorded sessions and we have live sessions. Live sessions goes for 3 months approximately. We cover approximately 40 hours of live sessions. We meet over the weekends. This course is for the weekend, Saturday, Sunday, 7:30 to 9:30. 7:30 p.m. to 9:30 p.m. IST, Indian Standard Time. You can convert it to time zone. And we meet over the weekends, 4 hours, 3 to 4 hours over the weekends. And you can calculate 40 hours, friends. You'll understand that.
Is it like same time, like 9 o'clock this time?
Yeah, yes. How we started, right? 7:30, same thing. Yeah.
Okay.
And that's why
And there
we
will
have.
be no.
Yeah, go ahead.
Sorry. Since it's December, so I believe that there will be no break. Like it's going to be consecutive Saturdays and days, right?
Okay. See, definitely if see, it depends. You see, I don't have any problem with the breaks as such, but it's December, and if it's coming in the last weekend, people are asking in the group. If I take a vote, actually, I don't go.
Fine. Okay.
Right, I take a vote. If most of us agree wants leave, they're traveling, what can I do, right? So very much flexible on these things. If important things, last weekend is coming, or let's say Christmas came or New Year 1st of Jan came, I don't mind giving off on that day particular, and we'll compensate, right? We'll compensate. We will do that something, right? So we have the live sessions. So one question that I always get: how are we gonna manage this big vast course in this 3 months? So we divide into recorded. I give you recorded session, my recorded session, and when we do the live sessions, both. And you can ask me questions. Earlier, I used to take this long. It used to be go very long. So that's why I come up with this 3 months of thing. People get time also. So friends, this core Java and Python, they are recorded sessions. Okay. The Shell Linux part is a recorded session, and the Java troubleshooting performance engineering is a recorded session. You can get it on day one. You can continue to learn on that. Everything apart from that is live sessions. So Linux. Go ahead.
Performance testing, right? So you will show us like we have to install like all the things and test watching the recording.
Exactly same live recording. It's taken from my own live recording.
Okay.
Those recorded sessions are from my live recording, which we are giving so that we don't do 5 months or 6 months of training. That's the main thought process. You can ask me any question. That's a live recorded session only. I'm going to give that.
Okay.
So it's going to be very much same. How are we doing right now, right? How do we do usually? So there are only two things recorded sessions: the Linux and the Java performance engineering. Okay. Apart from that, everything is live. Okay, everything is live. Whatever I told you, from AWS to Docker to microservices to SRE to automation, DevOps automation to monitoring tools, right? Everything is, or these automation, everything is live stations. And that's how we manage this, right? So if I have to just show you, this is one of my live sessions happening. Okay, September. This I have started this batch on September. In September, I started 17 September, 19 September. So you can see this is a weekday session, morning sessions, weekdays, 3 days a week we take up. So you will be given recorded session like this on daily basis. Whenever we record, it's a 1 hour of session. That's why you see this 1 hour only here, because 3 days in a week we take in the weekdays morning time. This session is for that. So you will see whenever we do the session, you will find the recording. I'll be sharing. You'll have a similarly playlist. Whenever we do the recording, have the session, you'll get the sessions like this, and it's a lifetime. You'll get it. So this batch is not completed. I have just reached till Docker. As you can see here, and if you look at the cloud part, how much I have covered cloud part. You can see this session from here only. Cloud is started. EC2 Linux. I just give the brief of Linux here. And you can see this cloud start continued 1, 2, 3, 4, 5. You can see this count till cloud going, cloud till still going. If EFS, S3, load balancing, auto scaling group, VPC, databases, microservice. Till 20 sessions I've taken for the cloud, 18 to 20 sessions, 1 hour. And then Docker just completed. I'm going to start Kubernetes next week now here. So it's going to be detailed. Okay. Going to be detailed. These are live sessions, and you will have recorded sessions also. As I told you, the Linux one like this, you'll be getting like this. Very simple, 3.5 hours of recording. Enough for you to know what all you know. Enough for you to get started on Linux. Very basics from very scratch, and you'll be good to be comfortable. Same thing for the Java performance engineering. We will give you that. There are some 10 to 11 hours of sessions, and we talk about Java performance engineering here. Right. Apart from that, we get Java coding and Python scripting, Python coding. That's not my recorded session, but you're gonna get as a want to learn more. Let's say somebody wants to learn Java, then go ahead. And want to learn Python in detail, go ahead. But I'm going to tell you what Python scripting would be required. How do we talk about that? I'll talk about the shell scripting and Python scripting in the automation module anyway. Right? We have a Python module. We talk about that separately. So I hope we have understood about the course. Now I'll open for the Q&A, friends. Right? Please ask me any questions if you have. Go ahead.
Are you going to cover the SLO, SLI, and S?
Definitely, right?
SLO?
Correct. I was showing you, right? This is the very top. I told you, right? This.
So
Okay,
this
got
is you're going to provide and show us online during the class time. But how about getting hands-on for us?
You will
Do we
be
get any-
everybody. When I say that hands-on for me, you would be doing it. The expectation that you would be doing it, and everybody would be getting a see. Where do we practice? We practice in cloud, and we are learning cloud. So I would be instructing everybody to create an account in cloud. And the way I'll be getting a server, the way I'll be connecting to the server, I'll be getting storage services, security services. You all will be doing that the same way. So I'll be instructing you to create a cloud account, and so that you can all practice.
So you will
Does
show
it involve
us
any does it
Go ahead.
involve any paid services in AWS cloud which we may have to use, or
Yeah,
only
see,
free?
we have to use, right? EKS is not free, right? But you will not pay, even if you have to use paid services, the cloud bill is not going to be more than 100 or 200 rupees in this for the entire course. So don't worry. I'll tell you about cost optimization also. That's one of the topics we have. How do we optimize the cost as part of SRE? So I'll talk about that, and you will not be incurring more than, it will be in the double digit only, right? If you just follow my instructions, your cloud bill,
Okay.
you're not going to be in triple digit also.
Yeah, Roshan, my question is that how much networking is required for this particular role? Means, as you already have covered the networking topic also in this.
Very much, very much. Networking is the backbone. How the applications communicate with each other, the security, because networking is directly to do with the security.
Yeah.
Because if you open ports which are not required, if you get public IP for all the servers, that's problematic. So we cover in detail about VPC, right? If I have to just show you from the live session, okay, I have this open. If you talk about networking, we talk about CIDR VPC creation. I started here. Default VPC, I started from here. Talk about CIDR VPC, private subnet, NAT gateway, NACL, DDoS attack. What is that? We cover this 5 sessions and then the remaining topics of EFS. So approximately 5 sessions, 5 hours. We're going to talk about this 5 to 6 hours. We'll talk about networking only, right? So 5 to 6 hours. Yes. Very, very important. VPC is VPC service is very important to cover.
The
I think this is
database concepts is also there, right?
Absolutely. So when I say database,
That
how do
is,
we use database in the
like-
cloud? Go ahead.
Mhm.
Go ahead. Please go ahead. Ask your question.
I think in the,
Yeah.
I mean, in the course, you database, okay. I saw something called database performance or database separate this one, right? Not just this.
Okay, that's a database tuning. That's database, same thing. Database, I'll talk about that. How do you achieve high availability?
Okay.
How do you achieve high availability in the database, in the cloud? How do you achieve performance using the infrastructure? I will not talk about SQL tuning right here in this course. I will not talk about how do you do SQL tuning or tuning of your queries. No, I'm talking about from the infrastructure, from the cloud perspective. How do you make it highly available? How do you increase the performance from the infrastructure? SQL tuning is not part of this course.
Okay.
I'm going to show you, I'm going to install database. I'm going to install database in the container. I'm going to install database in the AWS service. And I'm going to walk you through everything about how do we achieve high availability of the database? How do we performance of the database, right? Through using read replicas. I will talk about that, not SQL tuning.
So here we get understanding about AWS CloudWatch for the monitoring.
Okay. From the CloudWatch, from the AWS CloudWatch, yes.
Okay. How about Prometheus,
Correct.
and
Correct. So that's why I have pushed that in the here separate topic. So from the observability perspective, we talk about 4 things. The CloudWatch as part of AWS. When we talk about Linux, how do we do self-scripting and do monitoring in Linux? Different metrics that we need to capture in Linux for the monitoring purpose. Then Prometheus and Grafana and Elastic Stack. These 4 things in the observability. And when I say, go ahead.
This is live class, right?
Live sessions. Again, please
Okay.
make a note, only the Linux and the Java performance engineering are recorded session. And I've given you this also. Only I mentioned this recorded session. Okay. This recorded session and a recorded session. Only the Linux. Only these 2 are recorded sessions. That's all. If you look at this, go ahead.
How we will practice Linux? Like if
Yeah.
I have a window machine, like.
No, you will not have Windows machine. That's why we will ask you. I'm going to instruct you to get a cloud account. And we'll create a server here. We will not use your Windows to practice Linux. We'll create a Linux server. We will install application. We will go inside this. We do it. We call it SSH.
Okay.
Right? So that's the fundamental. That's the fundamental I'm talking about here. We are lack fundamentals. If I tell you that we do SSH in Linux box, how many of you understand this language? And it's a very basic. If you do not know, if you're not able to understand this, means you're not comfortable with Linux, you're not comfortable with the server, right? And which port do we use SSH? Let's say we'll ask a simple question. I know few of you would be able to answer, but not most of us here. we use port 22. If it's a Windows server, we do RDP protocol 3389 port. These are very fundamentals, right? And that is what we lack on, and that is what this course focuses on. We will talk about the scratch things. Go ahead, Pankaj.
Are we going
So
to do a real-time project during the course of?
Can you? I'm not able to understand. Please, can you be louder, clear?
Are we going to do any real-time projects? Real-time projects.
Yeah, real time. Everything is hands-on. I'm going to install application. I'm going to create Linux server, install application, show you how do we do things.
Okay.
Everything is hands-on. Yeah. In
And
cloud,
you will be
everything has to be
telling,
hands-on. Go ahead.
okay. And you will be telling us, so how the daily day-to-day tasks will be coming in as a necessary engineer, because most of us are coming from the different roles and all. Okay. So once we get an opportunity to work on in any company as an SRE post completion of this course, so how we will get the work and what kind of work we will get in the data.
Once you learn, right? See, I understand your question. I understand you're not able to understand what you're mostly worried. How would you be doing it? So let me tell you this. Once you know this course, once you attend this course with full dedication, and I need commitment, okay? It's not just me speaking. It's real 2 hours of effort, 1 hour of effort that you do. That matters. Because I'm going to make things simple for you, but if you don't practice, you will not learn. But I can promise you one thing. If you follow my instructions, pay attention, practice later, you will find yourself at a very different level after 3 months. I will ask the same question to you, Ram, and you would say, yes, Roshan, I can manage now. You yourself will say, yeah, I feel good, I can manage now. Pankaj, right? Whoever asked.
yeah,
Thank
Roshan, I have a question. So right now you already have covered the Grafana and Prometheus in this SRE, role. So right now, yesterday I just had a discussion with one of my DevOps team guy. So he's saying that they are just started working on Datadog. So is it the
Datadog is like a
same?
commercial tool. Okay. So
Okay.
Dynatrace, that Datadog, New Relic are all commercial tools. Go ahead, complete your question.
So is it okay if I having the knowledge of this Grafana and Prometheus so I can easily work on that Datadog?
Absolutely right. Because again, that's it. So you understand this. There is a paid service. With paid service, support comes. If you understand how do you install application in your server, in Datadog, you don't have to install server. Okay, tell me one thing, I'll tell you. If you install how to set up your own mailing server in your server, is it difficult to use Gmail?
No.
That's the response I would give you. Exact same question you're asking. If you know how to set up your own mailing server in your own server, in your own EC2 instance, if you know how to install your own mailing server, is it difficult for you to use Gmail? That is because when you use Datadog or Dynatrace or AppDynamics or New Relic, you don't install anything. You only instrument it because they handle the server, because they are as a service, monitoring as a service. Like we have a word called software as a service. Gmail, Facebook, YouTube are software as a service. We don't know how it is installed, where it's running, but we use as a service like Salesforce or Workday. We use it in our company, right? Same thing, Dynatrace or Datadog is just monitoring as a service. The dashboard that you need will not change, right? If I use my monitoring tool, will my CPU, memory, all the metrics, all the key panels gonna change? No, only the way we create would be different, right? The way we use the UI would be different. The look and feel will be different. But we get a huge support from Datadog because it's a paid service. You're paying some $50,000 a month. They're gonna give you a paid service. You understand the point?
Yeah, I got it.
Perfect.
Sir, this course is how different from DevOps? Like whatever the courses we will cover in SRE here, So what is the difference? Like, can we also cover this in DevOps also? Same thing?
It is the part of DevOps. This course is very much good for anybody working as a performance tester, engineer, and you want to become a cloud performance tester or engineer. If you are working as a production support, we're looking for a DevOps engineer. If you're a DevOps engineer looking for some good knowledge, helpful. If you're looking for the SRE engineer, so we cover these three things in this course. So it's gonna be helpful. It's a DevOps course. DevOps, SRE, there is not much difference. See, the role of a DevOps engineer, I'll tell you simple. I attended one of the workshops. I took one of the workshops recently. I'm not sure if you get to see that. There's a recording available in the web. If you go to Isha Training YouTube page, you will get it, my recording. So DevOps engineer responsibility is to deploy the application in various environment. Deploy the code. Developer is developing the code. DevOps engineer more main role is to deploy the code in various environment. Staging environment, pre-prod, prod, and through automation. SRE engineer responsibility is to make sure your system is highly available, reliable in production. So we talk about deployment here. We talk about how do you make your system highly available in this course. We talk about both the things.
Yeah.
Yeah, I hope you understood.
Yeah, I understood. But in DevOps, what other things we need to cover? Like, just for asking. So SRE, we are covering all these things. But at
In
the DevOps
DevOps
side,
also you cover same thing.
same thing mostly.
Same thing, and you don't need to be a troubleshooting expert. That's all.
Okay. Production troubleshooting.
You don't need to be an expert in DevOps. You're only responsible to deploy the code.
Okay, can you please make me understand, like, what is the difference between SRE and production support? Like, it's same or like?
See, again, you need to watch that video for sure. Okay, because I have covered in detail, but I'll give you a simple thing. There are three SRE roles and responsibility. SRE has got multiple roles, multiple, I would say, the level. We have level 1, level 2, and level 3, right? In level 1, we have the production support we do. So we work in shifts, okay? People work in shift. They will have 8 hours of shift and they will monitor. See, the applications like Amazon, Flipkart, they need continuous monitoring. Okay, you cannot afford for these applications to go down. You need a dedicated person. If the issues come, you need a dedicated person to be available to find out the issue, to troubleshoot the issue. Okay, in production. One of the joke that AWS was down in Diwali because most of the people were on leave, right? Even AWS has had a downtime during Diwali. So you need people to be available, right? So they work in shift 24/7, and we have 8 hours of shift. So that's level 1. Then we have level 2, and we are preparing for that level 2 here in this course, right? Where we are talking about troubleshooting. We're talking about setting up monitoring tools. We understand the architecture of the application. We're talking about content. We're talking about in technical details. Level 2 is what we're talking about here. And level 3 is the subject matter expertise. So that is the difference. So if you say SRE engineer, when you call yourself SRE engineer, we're talking about level 2 basically. Right? When you say production support, you're basically talking about level 1, where you work in shift and you're just doing monitoring of the application, and you should understand production support, right? If you understand, see, the feel should be there. Okay, you should understand mindset of the production support. The problem is there in production. Can you be relaxed?
No.
Right? That's the mindset change in mindset we're talking about. So if the issue is there, we don't look at time. Okay, what time it is? My time is over. My shift is over. No, production issue is there. You have to be available. So that is the mindset shift. Performance tester engineer work in lower environment. If the issue comes, okay, lower environment, right? Application is not going to go down. Customer is not impacted. But in the production, customers are impacted. You have to resolve the issue right there. And that is the mindset I'm talking about, right? So we are talking about level 2 here as a site reliability engineer, not the production support. We're just doing monitoring and letting just letting the information, if the problem comes, they have some SOPs, standard operating procedures written. They follow the SOPs, and if there are things beyond their control, they call level 2 engineer. That's how it happens. So that's the difference between a production support and SRE engineer.
I have a question.
Hmm.
Yeah, so how important is to have a coding knowledge for this course?
Again, coding, when I say coding part, you don't need to be a developer. Okay. If you are good at scripting, automation mindset, because we have a lot of opportunity of automation. If you're good at automation, that itself a very good thing. And because automation also is like a coding, but with the mindset is automating or the scripting, right? So you should know Python. Okay. Being a good SRE engineer, and particularly if you're a senior, if you're starting 3 to 4 years, you can manage without coding or some scripting. But if you're 10 years, you should know 8 year, 10 years, should know how do you write some code and to automate some stuff, right? We need to sometimes do some automation to remediate the issues, right? Let's say one issue comes. Let's say that every time this issue is coming. So people will expect you to automate that. When that issue comes, write a script to automate that so that we don't need to do manual intervention. So it is required. Scripting, automation with mindset is required. That's why the Python scripting is very important. Shell scripting and Python scripting is important. You may need to take a backup of database. How would you do that? Right? You need to write some script, or you have to take some dump to the database and store it in some S3 bucket. So again, some scripting is required. Or you have to write some cron job. You have to trigger a script every day. So you need to write a cron job, write a script. Should be good with Shell scripting and Python scripting. That's good enough.
From Azure side, you not cover anything, right?
Again, told you, right? If you know one cloud,
Yeah.
it's so easy to learn other
Correct.
cloud.
Yeah.
If I take multiple cloud, then we cannot take these many topics.
Yeah.
So
Roshan,
this
one
course is totally over weekends. We don't have any
Weekends.
regular batches.
Regular batches will be there, but right now batch is under progress and it's already been 1.5 months. So my regular batch would be happening maybe in Jan or Feb. I'll be starting with a new batch, but this batch right now will be the weekends, Saturday, Sunday, 7:30 p.m. to 9:30 p.m. Indian Standard Time.
Okay. And if the regular batch is there, it would be only 3 days a week?
3 days a week. Yeah, mostly Monday, Wednesday, and Friday. Yeah.
And in the mornings?
Mornings,
IST.
yes. IST 8 a.m. to 9 a.m. Yeah.
Okay. Thank you.
Roshan, small question regarding that, what you said, like a level 2 SRE engineer. Suppose, let's take an example. So I have deployed as a level 2 SRE engineer for a project. So what are the main roles or day-to-day activities should I do? And for example, now you can take any testing part, like we will have to take the requirements and we have to do the initial and scripting things, and after that is something that is some part in the testing side. But as SRE level 2 engineer, so what are the main roles and what is the starting? Suppose if I deploy as a SRE 2 level, so what are the initial things I have to do when I deploy into the project, and how can I start the working as a real time?
See, your main role is to make production stable. Okay, that would be your main role. If you have to take up issues in the field, now beat any issues, particularly its response time high, you're getting high status code, errors are high, you have to drill down. And that will only happen when you have a troubleshooting mindset. You should understand application architecture so that troubleshooting is a skill. So you narrow down the issue and let the right team know if a problem is the development team, or if it's an infrastructure scaling issue, you have to fix it. Auto scaling is failing, you have to fix it, right? You have to recommend or talk to the performance team, or you can also recommend if you're comfortable, right? Or if you know some application related issue, some deployment related issue, you have to talk to the right team. development team. So that's
Okay.
primary role.
That means most of the times it's the production related, right?
Let me complete.
Yeah.
I have not completed my answer. So that's your primary role. Secondary role, let's say when things are good, you may be asked to do some automation, like infrastructure as code using like Terraform. We have a tool which can automate infrastructure. Let's say right now they are provisioning applications manually. They're provisioning servers manually. But they're asking you to write some Terraform script using which the infrastructure as code, which will create infrastructure EC2 instance, VPC, databases, and get everything up and running, install. Because it's practically not possible to do manually create infrastructure, right? So we need to write some script. So you'll be involved there, right, as a secondary job. Third role could be that there is some manual activity in production team members you're doing, and you would be asked to automate that. Some database backups or something, a bit taking a dump. You are just doing manually, taking time for your team. You need to help them automate it. Fourth important thing is that if you don't have a right alerting, see the issues. How would you know about the issues? Nobody would look all the 100 panels all the time. So we need to do alerts. If you see the problem with the alerts, like a lot of information alerts are happening, lot of too many alerts are happening, people may ask you to fix alerting, put efficient alerts. I'll give a simple example. Let's say you are observing a trend of CPU, let's say 60%. Or 270% from last 2 months. And if you put an alert at 65%, what will happen? Your email is going to be flooded. Yes or no?
Yes, correct.
But with no action item. So you need to fix that, right? So if you look at the trend, you need to be smart enough to understand your 60 to 65, 60 we will not help, right? So you need to have alerting at 70%, that will help, right? So these are the roles, friends, we should do. Ask a second question.
Yeah, okay. Thanks, Roshan. But maybe what I understand, most of the times, I think as SRE engineer should always work with the production closely and to sort out the issues, right? That is the main role, right?
Right. But apart from that, I told you these things also. Helping at SOP is one of the roles. How, let's say you have alerts, but you need to help your junior member in level 1. If this alert comes, what do you want them to do? But if you're leading a team, let's say, then you need to tell your people, right? Okay, if this alert comes, do these actions, take this dump, take this memory dump, take this thread dump, and let's inform this person, call this person, or do something. If it's a real issue, call me. So you will need to write some SOPs, some standard operating procedures for your team, so that they follow that SOPs and act, because they are not that technical, right? And they are growing. They are still in the learning phase. So they are growing, and you need to help write SOPs also for them. So these 5-6 activities you do. And the role of a DevOps is totally different. DevOps talks about deployment, but you have these 5-6 roles which you do, which a SRE engineer does. Yeah, go ahead, ask your question.
Okay, thanks, Roshan. That's all. Thanks for information.
Perfect. Okay. Any other questions, friends?
Actually, I'm talking about front-end performance testing for mobile app and web portal. So how we need to approach for that? Is there any easy to covering or not as per this course?
We are not talking about performance testing here in this course. It's not a performance testing. Engineering infra. It is mostly we're talking about as an infrastructure engineering, as a platform engineering, right? As an SRE engineer, we are not talking about any Jmeter tool. How do you script API? Or we're not talking about this. Is not part of the scope of this course.
As a performance tester becomes a performance engineer.
Yes, right? Yes, correct. Cloud performance engineer. You can say things like this. How do you work in cloud?
Just I'm asking you. So as per this course, everything we have to we covered or not. Performance is also able to everything, like as per the front end, back end. performance engineers also everything is of infrastructure level and performance testing
Exactly,
front end and back end.
exactly, exactly.
So I'm because of what I'm asking you, like there is no any like front end talking about it. So I'm asking you.
No, what exactly your question? I'm sorry. What? How do we approach mobile performance testing?
For front end only, as per the recently I changed my project, they're asking like front end performance with mobile app. So what is the
Okay.
like
Okay,
is
how
covering
do
or
you
not?
approach it? You want to know how do we approach it, right?
Yes, exactly. Yeah.
Okay. See, for mobile, for front end, you have to measure the load time of the page. Okay. That's the
Yes, correct.
only
Yeah.
way.
Client metrics also have to find out
You
the
have to
issue.
measure the load time so you have to put some load. You can hit APIs in the backend and you need to write Jmeter Selenium script to capture the page load time. That's the only thing you need to do.
Yeah, correct. Yeah.
You have to use XPath. You need to know the elements for each
So
page.
can I know the how many maximum users for front end performance testing we can perform that application front mobile app?
See, I would say simple. I would say hit backend, put backend code, hit APIs, right? And just use one or two users to hit front end. Don't open all the 100 pages for front end and test it, right? So you use
Yeah.
API testing in the backend, keep on hitting the API, keep on putting the load, right? And then you can use one or two users for the front end to capture the page load time.
Actually, client don't want to back end. They want to check in front end only. That's why.
That's fine. I understand what they're expecting. Basically, why are you doing backend? For not for them to generate a prod scenario, to generate a production like scenario. See, if the load is not there, think about it. If the load is not there, right? In the like a prod, and if you capture it, the UI performance will not be right. Correct? So that's why to generate the load, I'm telling you this, because from the UI you cannot simulate the prod load. Okay, actual prod load, which is going to be very API, because once we log in, we hit a lot of APIs also backend. When you go to the page, you hit a lot of APIs also, right? So for that to simulate, I'm telling you to hit APIs in the backend so that you generate prod load and you hit one or two Jmeter Selenium for the UI, capture the UI page load time.
Yeah, correct. Yeah. I am using like Android Studio. The reason I am open like two devices, emulators. So this one currently I'm doing like. So just I want to check with you how many users we can perform content. I don't want to be like I installed 5 emulators. My system is hanging. Then after
Okay. Okay, yeah, that's what I told, right? That's what I'm telling you. Hit backend also to simulate prod load.
They want to check only prod only. They don't want. They don't. They.
Again,
They don't have
again, I'm
any
telling you,
production.
again, I'm telling you, the backend is not for them. Backend is to simulate prod load, simulate some load.
Yes, correct.
Okay, you give them the
That
UI
will be
page load time only. Okay. Any other questions related to the topic?
Yeah.
Sorry.
Sorry, you mentioned 40 hours of course, right? So it means 40 weeks, 40 weekends, or
40 hours means every week we'll talk about 3 to 4 hours, right?
okay, then it will be 10 weekends, 10 to 12 weekends.
Yeah. Correct.
Okay.
That's why it was 3 months.
It is Saturday and Sunday.
Correct. Saturday and Sunday. 10 to 12 weekends is 3 months, right?
This course mainly focuses for the DevOps, right?
Again, I think we all have understood, right? We're talking about who are we helping here? We're helping about production support, DevOps engineer, SRE professionals.
What I am looking is I am automation like testing. So we are using. I need to like learn on the AWS services how to configure it
Okay, so that will be covered as part of this course. So you are a QA engineer, but you're looking for these skills. Yes, you will be learning for sure. Yes.
Okay. You like help guide us for taking any AWS certification like.
Absolutely. Solution architect certified. Yes. Solution associate. We can try that. Yeah. SAC03. Yes.
Okay,
We'll
the
be able
beginner.
to. We'll be not beginner. Beginner is different. I'm talking about solution architect associate.
Okay.
Beginner without any problem after this course. Right. I'm talking about at the technical level. Solution architect associate. So I'm talking about this upon completion of the course, upon few guidance, you have to put some extra effort and we can target this particular certification here. This is going to be very easy. This practitioner foundation is going to be very easy. This is going to be going to focus this.
Okay.
And is there any certification available for only for the SRE engineer, Rushan, apart from this cloud?
See, there are available. There's local DevOps Institute. They do that. Okay. But the certification will cost you some $25,000 to $30,000. So there is an institute called DevOps Institute. They do this certification, but they will cost you. Yeah. They have some certifications. DevOps Institute. You can go to the certification and they have some certification on the SRE part. So you can try that. Not required necessarily. So they have certifications for the different skills. DevOps Foundation. You can see this, right? DevOps leader, DevOps Foundation, SRE practitioner. So you can try certification here after this course.
Okay. And Roshan, one last thing. So just my understanding as an SRE engineer, so we are just building the systems on the cloud. Okay. And once it is ready, so we are handovering it to the respective teams like application or the database teams to install their own services on those boxes. Is that right? Or we are going to do that installation of DB and or storage or whatever it is?
See, when I say again, you're talking about, I think I told you 5-6 responsibilities, right, Mali? I told you 5-6 responsibility already. In that, I told you one of the responsibility was infrastructure as code, right?
Correct.
We need to write script which can help us deploy entire application. Right?
Okay.
So that comes under that.
Okay. Okay. And if there is any issue arises with the application like the latency, so if they come and say like we need to fine tune some DB queries to reduce the latency.
Then DBA will help me, or the developer can help on that, right? The person who owns that has the responsibility. Who wrote that query?
Okay.
If the query is not optimally good, if the slow code, developers should fix those things, right? We can help them fix this query. This you can on the monitoring tool, data CloudWatch, they will tell you which query is developer know or DBA know to fix those things.
Fine.
As an SRE engineer, our responsibility is not to own everything. Our responsibility is to make sure production is highly available. We have to take help of development team, operations team, anybody in the organization. If they own it, they are responsible. If I'm looking at production, it doesn't mean that I own everything, right? If the problem is with them, they have to fix it. But I need to help them to know that this is your problem. Right? If not, they will come back to us. No, this is not my problem. Unnecessary discussion. So we need to do some initial analysis and let them know that that's your problem, right?
Yeah.
Okay, perfect.
Kumar, a quick question. So in this age of AI, so would you also let us know on how to create, agentic AI or bot on, automating those
First of all, we need
infrastructure?
to again, I got your question. See, again, I told you, right? To use AI things, we need to be very much comfortable with basics, right? If you do not know how Kubernetes work, can you write anything? Can you develop anything in the AI?
No, as you anyway gonna show us on
Right.
that, so would you get us have exposure on
Well,
those two?
first of all, we're covering basics here. I can tell you a different scheme. We cannot cover everything, right? We are taking care of basics, the standard things, right? And then that would be the next thing when you join a company, because that field is vast. You can automate, you can go to a different level depending on the issues, depending on what is the scope of change. So we are focusing here. I don't want to promise anything unnecessary, right? We are focusing here on the fundamentals. We should know what it is first, and then we talk about those things. If after understanding, if you ask me, you and me can have a good discussion on that. First of all, we need to be on the same level, right? For me to explain and for you to understand. So first of all, we'll reach there. And then apart from that, if you have a question, how do we do this, Roshan? Now, okay, we have learned this. Okay, now how do we achieve that? I'm going to give you ideas. I hope I answered your question, Srikanth.
Yeah, yes, got you. Yeah, Roshan, yeah. Thanks.
Okay, perfect. Okay, friends. So any other questions? If not, we are good for the day, friends. Okay. I hope I have made your time worth spending, and I hope you all have learned something. Can I get a thumbs up from all of you? Yes, we have learned something here. That would be enough for me. Amia, you have raised your hand. Yeah, if you have a question, you can. There's thumbs up also.
No, no, I'm good. Yeah.
Okay, perfect. The thumbs up icon also means you're good. Okay, perfect. Abbas, you have a question?
No, I'm good with.
Okay, so there's a thumbs up option. Okay, this hand raise means question. Thumbs up means we are good. Okay, there's a reaction. We have in the react we have a thumbs up. So if you could do that, means we are good. Okay, perfect. So much, everybody. Thank you so much. We'll meet tomorrow and discuss further. Tomorrow, going to our day one. Thank you so much.
Hi, Roshan.
Yes, yes. Go ahead.
Yeah, actually, I want to join the morning weekdays batches. So how much I need to wait?
You need to wait another 1.5 months to 2 months. Yeah, 1.5 months for sure.
Roshan, in between, suppose we are not able to, after 1 month or something, we're not able to join, we can join also later, like, no, on other batches, right?
Yeah, you
In
can.
case.
Why not? Yes.
Okay, if I start from this batch and then later I will switch, and then this is equal to that batch is already running. So is it
I could
possible?
not get you. Where do you want to get started? This weekend batch?
Yeah, from this weekend batch.
Okay, you can start and you want to join there also.
Yes.
To see how things are happening.
No.
Fine. Yes, that is
Actually, I'm
doable.
comfortable with this morning and weekdays.
I got it. But we are talking about Kubernetes here. And for that, you need some prerequisite knowledge. I don't know how much knowledge you have. I don't want you to feel, I don't want you to feel what's going on.
Yeah.
So as long as you're able to understand everything there, I'm fine. I don't have any objection. You can attend both the batches at the same time also.
Yeah.
Okay. Perfect. Yeah. Okay. Any other questions?
Thank you.
Thank you. Any other questions? Okay. Perfect. Thank you so much. We'll meet tomorrow and discuss further. Thank you so much, everybody.
Thanks, Roshan.